Hello everyone, in this video I'm going to show you how to graph quadratics, but I'm going to show you how to do it a little bit easier than last time. The first video is important because it's just to show you that to graph something you're going to need some points and you're going to need x and y. So hopefully by now you've learned that if you have a quadratic and all you see are x's, what you can do is you can get everything with x and all of the numbers on one side of the equation, and then on the other side of the equation, you can let that be the y. I'm letting my polynomial for number 2, my polynomial, which is a quadratic polynomial, I'm going to have y equals x squared minus 9x minus 10. And to graph this, the easy way, easier than plugging in those numbers that we did last time, we should factor it. So y is equal to, let's make the factoring x, negative 10 on top, negative 9 on the bottom, 10 and a 1, and let's make the 10 negative. Negative 10 times 1 is negative 10. Negative 10 plus 1 is negative 9. Divide by a. So my factors are x minus 10, x plus 1. With these factors, we can see that y is equal to x minus 10 times x plus 1. And if we look back at where we started, we had y is equal to 0. So what that means is, well, you've been solving for quadratics before. You solved for them last week. You could, if y is equal to 0, then we have these factors, which are the quadratic, and to solve this, you did it one at a time. X minus 10. You solved this one at a time equals 0. X minus 10 equals 0. X equals 10. X plus 1 equals 0. X equals negative 1. And if you look right here, it says that y is equal to 0. So if y is equal to 0 and x is equal to 10, then that gives us the coordinate 10 for x, 0 for y. And if x is equal to negative 1, y is equal to 0, then we have the other coordinate, negative 1, 0. And if we were drawing a line, if we were graphing something linear, you only need 2 points to graph something linear. But to graph a quadratic, you need at least 3 points. To graph linear, you only need 2. To graph a quadratic, you need at least 3. The reason why you need 3 is because 3 points shows the curvature. And the curvature is like the steepness of the parabola, the general shape / general shape of the parabola. That means like how skinny it is, how fat it is, whether it increases very rapidly or if it takes a lot of time, a lot of x's. Do I need to plug in 100 to get a good y value, or do I need to just plug in the number 1 and I'll get a good y value? So we need 3 points. Here are 2 of them, and how we can get the next point is we can find what's in the middle of these 2 points. These 2 points are called roots. These are called the roots. And if you remember from the second 9 weeks of our class, or maybe even the first, the roots, the definition of a root is the x-intercept. But since now we have 2, because we have a parabola, parabolas are u's, and here we have 2 roots, which means we have 2 x-intercepts, we need to find out the middle of this parabola. The middle of the parabola, if it's going to touch, if we have a general shape like this, And we know it's going to touch at 10, and we know it's going to touch at x equals -1. These are x's. I'm taking the x's from each of those two coordinates. We know that we're going to touch here and here. The next best thing for us to find, the next best point, is the one that's directly down the middle of those, where the vertex is going to be. The axis of symmetry is 2 m's. The axis of symmetry is the middle, and if we find the vertex, it will show if the graph opens up or down. We don't know if we're going to have a U parabola or an N parabola until we find out where the vertex is at. So in my key for yesterday's or a few days ago's worksheet, we found the midpoint. We want the midpoint between -1 and 10. So to get the midpoint, that means you want to find exactly what's in the middle. To find exactly what's in the middle of -1 and 10, we want it's kind of like the average. We're going to add the two numbers together and then divide them in half. So 10 plus -1 divided by 2. If we find the average between these two, it's going to put us directly in the middle. 10 plus -1 is 9, divided by 2 equals 4.5. So the midpoint between these is 4.5. So that means that right here, this x value, where the axis of symmetry is 4.5. And if we're going to find the y value of the vertex, that means that the vertex is somewhere on this vertical line where x is 4.5. So if x equals 4.5, then y is equal to, well, what was the equation up there? X minus 10, x plus 1, or x squared minus 9x minus 10. To keep it simple, I'll do x minus 10, x plus 1. I'm going to plug it into this version of the equation. So y is equal to, we're going to plug in this x. We're going to put it for x. We're not multiplying, we're putting it in for x. 4.5, minus 10. 4.5 plus 1. So y is equal to negative 5.5 times 5.5. So y is equal to whatever 5.5 squared is, and I have my calculator. 5.5 times 5.5, turn that answer negative 30.25. So then my last coordinate that I got that I'm going to graph is 4.5 for x. It was the middle between the two roots, the two x-intercepts, and the y is going to be negative 30.25. So with this point, we know that my vertex is going to be down, and this isn't to scale, but this is going to show me my general shape is going to go like this. And you could just label 4.5, negative 30.25, and we can tell that these other 2 points are x-intercepts, so that means that the y is going to be 0. Let's do another example. How about number 8? 2x minus 3, 2x plus 7. 8. 2x minus 3 2x plus 7. Make sure that's right. 2x minus 3, 2x plus 7. And this is equal to y. Our first step would be solve for x. 2x minus 3 equals 0. We're going to solve for the roots. 2x minus 3 means that x is equal to 3 halves. And 2x plus 7 equals 0 means x equals negative 7 over 2. So my two coordinates are 3 halves, 0, negative 7 halves, 0. And the reason is these are roots. Whenever I had you solving those quadratics before, you were solving for the roots. I just didn't tell you. The roots, which are x-intercepts on a graph. The x-intercepts. That's why we can just plug in 0 for y, because if we're on the x-axis, then y is going to be 0. If we are on this line, anywhere on this x-axis line, the y is going to be 0. So we have one point at 3 over 2, one point at negative 7 over 2, negative 7 over 2. If this one's 3 over 2, I just made this spot like twice as far away from the origin. And now we need to find out what's in between those two. What is halfway between the left root and the right root? Let's do that the same way. Add them together, divide by 2. 3 halves plus negative 7 halves divided by 2 equals negative 4 halves divided by 2 equals negative 4 over 2. Well, how about we just reduce that? 4 divided by 2 is 2, and we're dividing that answer by 2, so we have negative 1. So at negative 1, that's not to scale. Wherever halfway between these two from left to right are, negative 1 is going to be there. That's going to be our axis of symmetry. Halfway between the roots is the axis of symmetry. And once we plug that in, x equals negative 1, we're going to plug that in to find the vertex. Plug in x equals negative 1 to find the vertex. Well, we already found the x version, but the vertex is y coordinate. So we're going to take this equation from up above, 2x minus 3, 2x plus 7. Those are equal to y. And instead of putting x, we're going to put negative 1. Y is equal to 2 times negative 1 minus 3, 2 times negative 1 plus 7. So 2 times negative 1 is just going to make that 2 negative. And this 2 will also be negative. Negative 2 minus 3 is negative 5. And a negative 2 plus 7 is also a 5. But this one's a positive 5. So we have negative 5 times 5, which makes negative 25. And that leaves our last coordinate, the vertex, is going to be negative 1, negative 25. So let's put that on this graph. Somewhere down here is going to be negative 25 for y. And on the axis of symmetry is where the vertex is. And it means we're going to start at the vertex and go up through the left root and up through the right root. It seems like we're doing a lot, but we solved for the root, which takes no time at all. We solved for the root for the first step. We found halfway between the roots for the second step. Then we plug in that halfway number. The halfway number, I'm not trying to erase, I was trying to highlight. The halfway number was negative 1. That's where the axis of symmetry is. Once we know the axis of symmetry, the vertex has to have that same x value. So we plug that in, and that's going to give us the y for the vertex. Once we solve for that y, that's our last coordinate, the third one that we needed. We plot 3 dots, and then we can connect those with our curve to make a good old parabola.